In section 3.5, we're going to be turning our attention to focus on taking derivatives of trigonometric functions, so like the sine, the cosine, tangent, etc. So let's start here by supposing that maybe we just wanted to try to find the first derivative of the sine function. Now again, if we don't know a shortcut rule already for taking the derivative of the sine, then we would have to go ahead and start by using the definition of the derivative. So if we use the definition of the derivative, we could start by saying that f prime of x would be equal to the limit as h approaches 0, and then remember I would have to use my function with x plus h plugged into it minus the function with just x in it all over h. So again, this is our classic slope formula here. So now, I got to figure out how to evaluate the limit. Okay, this is really weird because, again, I can't directly plug in 0 right now. That would force me to divide by 0, which isn't good. And I don't really see any other way I might be able to directly simplify this. I can't really factor anything or cancel anything out top and bottom. So what am I really supposed to do here? Well, one thing that we actually may be able to see is that this portion of the numerator, sine of x plus h, actually represents a nice trig identity that we may possibly recall from trig classes that we've had in the past. So whenever we had the sine of one angle plus another, there was a way that we could potentially re-express this. You might recall that it was something like the sine of the first angle times the cosine of the second, and then plus, and we reverse the order of the angles, sine of the second angle and cosine of the first. So what we're going to do is try to use that sort of identity here. Now, if you don't remember this identity, don't worry about it. It's not one that I would necessarily have expected that everybody was just able to pull from memory. But identities are very, very useful, and so it's good to at least be able to recognize when we might have an identity to be able to use, and at least know where to go look it up. So let's go ahead here and see what happens if I replace that green portion of the top of the fraction. Now, obviously, that's going to make my numerator much, much longer. Let's see what we're going to end up with. I'm going to have sine of x times the cosine of h plus the sine of h times the cosine of x. And then, of course, I still have my minus sine of x that was up there originally, and all divided by h. Now, again, it looks like I've made this numerator really, really ugly, but I've actually been able to create now two different terms up here that both have a sine involved. And so what I'm going to do is kind of rejumble the order of things in the numerator and actually take that common factor of the sine out from the two terms which it currently resides in. So if I was to do this, I would be left with a sine of x. Notice if I pull it off of this term, I would be left with a cosine of h. Oops. Let me rewrite that. I'd have a cosine of h, and then if I pull it off of this term, I would just have a minus 1. Of course, I still have this plus sine h cosine x sitting up there that I haven't touched at all, and everything is now over h. Now I'm going to go ahead and rewrite this just a little bit more. I'll notice again that I have two different terms in the numerator, and so I could separate this one fraction into two different fractions. And then using my limit laws, I could take the limit of each of those fractions. So I'm going to have this first fraction and a limit of this plus a limit of my next fraction, which is just going to have the sine of h times the cosine of x over h. Now, it would be really great if I could try to work with these limits at all and try to evaluate them. But really, there's only two final simplifications that I can probably make here. I'll notice that in the first fraction, I have a sine of x. Notice h again is the variable that the limit is controlling, and so sine of x has no h's, and therefore it can be treated like a constant, meaning that I could pull it out to the front of this limit. Now, if I do that, what I'd be left with is just a cosine of h minus 1 in the numerator over an h. And if I was able to figure out this limit, I could figure out the first kind of half of the derivative. Over here, notice I have a cosine of x that could be pulled out just like the sine of x was over here. And that would leave me with a limit as h approaches 0 of the sine of h over h. So the tricky part, though, is how do I deal with these individual limits? Ultimately, what we can see is that determining the derivative here of the sine of x is going to ultimately boil down to being able to figure out each of these limits. If I can find them, I'll be in good shape. So I'll even kind of summarize that here. I'll say that finding f prime of x will depend on finding the results of these two limits. And by these two limits, I mean those two blue ones. So what we're going to have to spend some time doing in the next video is figuring out what exactly are the answers to these limits, and they're not necessarily easy ones to see or to spot immediately. And so we're going to have to take some clever approaches to try to figure out what their final values would actually be.